Alright, so in the previous example, it went down at a flat rate by $100 per year. So going from 1,500 down to 0. In this example, which is more realistic, Lachlan's barber chair goes by reducing balance depreciation. So the difference, remember, is flat rate will look like this. So that's n years, and that's Vn. Whereas reducing balance will look like this. Alright, that's normal depreciation. It flattens out at the end, alright? It doesn't lose as much value year to year by the end. Now, if the scrap value after 15 years is $100, i.e. once it goes below that, he's getting less money for selling the chair than he gets if he scraps the chair. That's what that means. It's better to scrap it before it gets that low. What's the annual depreciation percentage? So to do this one, we've got to go back to what equation we used to do reducing balance depreciation. So remember that Vn is equal to V0, which is the original value, times by this multiplier. 1 minus, because it's depreciation, R over 100. We don't know R. Okay, to the power of n. That's the depreciation, reducing balance depreciation equation. Now, in that equation, we have a bunch of the information, all right? We have the scrap value. Okay, that's going to be Vn. That's the future value. So 100 equals the original value, which is 1,500, times. Now, we don't know this whole multiplier yet because it's asking us what is the annual depreciation percentage. So we're going to leave it as 1 minus R over 100. We don't know R. But we do know that this multiplier is used 15 times. It's for a 15-year repeated period. Okay? If you were to solve that using your solve function, it will tell you what R is. And I can't remember what R comes out as, so let's just do it on the CAS. So we've got solve 100 equals 1500 times the multiplier of 1 minus R over 100 to the power of n. No, sorry, we know n, it's 15 years. And then that's comma R, because we want it to find R. Alright, so what we're saying here is 1500 is multiplied by that bracket's multiplier 15 times. And in that time, it reduces it down to 100. Okay? The thing is, we don't know what R is. And so that's what this solve will do. So R was 16.5%. So that's how much it had to drop each year for 15 years in a row to get to $100. So that's your solution.